It's important to be familiar with the world of binary, and we're going to have some fun with that in this video. Let's jump in. To maximize your time, here's the opt-out questions for this video. Go ahead and take a moment, pause the screen, read those 3 questions. If you're comfortable with the answers to each of those, go ahead and skip this video. I'll see you in the next one. Otherwise, hold on to your seats because we are in for a ride. I'd like you to imagine that you and I have walked into a showroom floor. It could be cars or boats or what have you. And on one of the items that we're looking at, it has a price tag and it says this, 45,239. And I want to ask you, how much is that? And I'm not talking about euros or dollars or pounds. I'm talking about the actual number itself. Now you might be saying, well, Keith, this is really obvious. It's 45,239. That's the number. And how did you get that so quickly? And the reality is because we've been using base 10 numbering system for all of our lives. It goes something like this. We have several positions here. For example, the 9 is in the 1s position, and the 3 is in the 10s position, and the 2 is in the 100s position. The 5 right here is in the 1000s position, and the 4 is in the 10,000s position. And all we're doing, because we use a base 10 numbering system, is the first number is always a 1, and then the next position is times 10 and times 10 and times 10 and times 10. In fact, we could go all the way down, just continuing to multiply that placeholder by 10 by 10 by 10. And really it was 4 10,000s, it was 5 1,000s, it was 2 100s, it was 3 10s, and 9 1s. But this is so second nature to us, we didn't have to break it out like that. In fact, when we count, for example, our numbers go through 0 through 9. So we have 10 distinct numbers to play with, 0 through 9. And when we count, we do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do we do next? Oh, we're out of numbers. We simply carry the 1 into the next position, and we put a 0 here. So 1, 0 in decimal represents 1 10 and no 1s for a total of 10. And then we go to 11 and then 12. And then if we get all the way to, for example, 999 by continuing counting, and we need to go 1 more, we carry the 1 again. And we have 1,000. So that means we have a 1 in the thousands position, and we have 0, 100, 0 10s, and 0 1s. Now you might be asking, okay, Keith, I totally get this. This is base 10, the numbering system most humans on the planet have been using our entire lifetimes. So what has that got to do with this thing called binary? Well, binary is simply a different type of numbering system. Instead of using base 10, binary uses base 2. So with base 10, we had numbers of 0 through 9, which are 10 individual separate numbers. And with base 2, we have 0 through 1. Which are a total of 2 separate numbers. With a base 2 numbering system, the first position over here on the right is a value of 1. And that's true for all the numbering systems that we use. Whether it's octal or hexadecimal or decimal or binary, that first position has a value of 1. And then as we move left, this next position is simply this first number times the base. So in the case of binary, it's base 2. This would be 1 times 2. I'll put that right here, and that'd be 2. And this next position over here, this next placeholder, if you will, is going to be this number times 2. So that would be 4. And as we go left, it would be this number times 2, which would be 8. And then times 2, 16. And times 2, 32. And times 2 again, which would be 64. And times 2 again, which would be 128. And how far could we go with that? The answer is we could go forever and ever. As long as there's numbers to use, we could continue to multiply that by 2. So with a base 10 numbering system, it went 1 and then times 10, times 10, times 10, etc. With base 2, we start with 1 and it's times 2, times 2, times 2, times 2, etc. It's also important to note that although we could go a really long way left here, we really only need to worry about 8 positions at a time when we're dealing with things like IP version 4. So here, my friend, is your very first expert exercise for this video. I want you to write out these value positions for binary. And again, the way to do it is you start on the right with a number 1, and then you simply take that number and multiply it by the base as you go left. So 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, and 64 times 2 is 128. And that, my friends, is what I would like you to do right now. So here's what I would love for you to be able to do. On demand, I'd like you to be able to write out this table of the actual weight values for each of the positions. On the far right, starting with 1, then times 2, times 2, times 2. You can also go the other direction by starting with 128, dividing by 2, dividing by 2, dividing by 2. That also works. And when you do this, if you're doing it on paper, when you write it out, to practice, go ahead and fold that part over so that when you do it the second time, you're not simply looking at what you did previously. Having this skill of writing out the binary weight values for the positions is an important skill. I wouldn't ask you to do it unless it was critical. So please take a moment and make sure that you can write this out on demand. So let's take a look at an example of how a binary number works. Now in binary, there's only 2 numbers that we get to play with, and they are a 0 and a 1. See, in decimal, we had 0 through 9, 10 different positions. In binary, we have 2. We have 0 and 1. It's sort of like a light switch. Either it's off or on. That's our only 2 choices. So if we had a binary number like this, that's 1, 0, 0, 0, 0, 1, 1, 0, holy schnikers, what exactly is the value of that number to us as humans? And the way to figure that out would be saying, okay, well, we have a 1 in the 128th position, so that's 128, plus 0, because we have no 64s, plus 0, no 32s, plus, okay, how many 16s are we going to add to this equation? If you're saying, well, Keith, it's like a light switch, right? It's either on or off. Because this is a 0, it's off, which means we don't have any 16s. So we're going to say 0 there, plus 0. And here we go. In this third position, we have a 1 on in the position that's worth 4. So what would we add down here? And if you're saying, well, Keith, over here we had a 1 on in the 128 value. We added that. I imagine that we would go ahead and add 4 for this position right here. And that is exactly right. So we'd add 4 there. And how about the 2? The answer is, yep, we have one of those. So we'll add a 2 as well. And then 0. And then it's simply a game of adding. All we're going to do, if we want to find out the actual value of this binary number, all we simply do is add these up. So it's 128 plus 4 plus 2, and that's it. So 8 plus 4 is 12, plus 2 more is 14. We'll carry our decimal 1 right there. That's a 4. 2 plus 1 is 3, and then we have a 1. And so the actual value of this binary number, 100000110, is 134. The key part that I want to make sure you have the ability to do is write out this table, if you will, of the actual values of the positions. That's the most important aspect. I would like to do one other exercise with you, and let's say we have a binary number of 0, 0, 0, 0, 0, 0, 1, 0. What is the equivalent value of that binary number? And again, to figure that out, you simply say, okay, we don't have any 128s, we don't have any 64s, no 32s, no 16s, no 8s, no 4s. We do have a 2, so it's going to be 2 plus, and we don't have any 1s. So basically it's 2 plus 0, and that is 2. So last week, somebody at the office sent around a note, and it said this. It was very, very funny. It said, there are only this many types of people regarding binary. Those who get it and those who don't. And the reason that's funny is because in decimal, right, that 1 would be in the tens position. It looks like 10, as in 5 plus 5, a total of 10 people. However, in binary, that same number of 1, 0 is representing a value of 2. So there are only 2 types of people regarding binary, those who get it and those who don't, which makes the joke funny. And for those people who don't understand binary, is simply a t-shirt that they read and simply don't get. So the actual process of doing converting with binary to decimal and decimal to binary, I've got a separate video for you and I just for that. Our focus in this video is simple. I want you to be able to write out these 8 value positions from right to left or left to right on demand. Make sure you do it accurately regarding the binary base 2 numbering system. Our action items for this video are real simple to make sure that we can write out the values for the 8 positions in binary, starting with 1 on the right and 128 on the far left. The other thing I would strongly encourage you to do is once you can write out that table successfully and comfortably, go take a look at the opt-out questions that are at the beginning of this video, and that will help validate what you've learned in this video. I have had a lot of fun. I really appreciate your time. I hope this has been informative for you, and I'd like to thank you for viewing.